Hi everyone. In this example, we're going to look at a function represented by a table, but we're going to be in the context of a word problem. So the word problem is about sunspots. So the sun goes through periodic cycles of sunspots, being common and then absent. The sunspot count is recorded, and we've seen some interesting patterns. So what we're looking at in this table is sunspot cycle number 23, and we've got the average annual number of spots, not sports, discovered each year. So the years are in the first row. So I'm going to say, these are our inputs, right? We're inputting y. I can see it right in the function notation. So we're inputting y's, which are years, and we're outputting n of y, which is the number of sunspots. So I'm just going to say number of spots since I don't have a lot of room. There we go. Okay, so we want to find n of 2002 and explain its meaning in the context of the problem. Okay, so we're being given the y is 2002. Y is what goes in the parentheses, right? So we want to say, okay, we know the y is 2002. What is the n of y? And the answer is 104. So the number in the parentheses is your input. This time we're being given the input and asked for the output, which is 104. Okay, and the meaning in the context of this problem is that in the year 2002, there were 104 sunspots. So in 2002, there were 104 sunspots. And again, I actually really love, I'll do this for myself. I didn't necessarily need it there, but just to remind me. So this is y and this is n, and y is the year, and this is the number of spots. So I labeled it on the table, but I really like having that visual on the graph personally. It helps me keep things straight. Part B is flip-flopping this. It's saying that the n of y, so this is the output, is 64, and we're supposed to solve. So the unknown thing there is the y. We're solving for y, find the year, and then explain the meaning. Okay, so let's erase what we used last time. We'll say, so now the output, we want to look in the bottom row, and we're looking for 64, and it's possible for that to show up twice. We certainly shouldn't have repeated inputs, but we can have repeated outputs, and it looks like it does here. It could show up 3 or 4 or 5 times as well. It could show up not at all, and then we'd say no solution. Okay, so we get that this is true if y is equal to 1998 or 2003. So those are my answers. The explanation would be that there are 64 sunspots in either of those years. So 64 sunspots in 1998 or 2003. So as usual, given either an input or an output in these, and you're going back to look for the other. And the trick with tables is really just to be very careful that you're looking at the correct row. People get a little tangled in their head sometimes and see n of 2002 and want to look at the bottom row, but the thing in the parentheses is always the input. So if you're given the thing in the parentheses, that's going to be your inputs row or column. Okay, the next one's looking for an average rate of change, which is always a little bit trickier. And we want to look from 1996 to 1999 and explain the meaning. And then we also want to compare to 1998 to 2003. So 96 to 99. So we're going to plug in 1999. And then we're going to plug in 1996. And we're going to subtract. And then that's going to be divided by 1999 minus 1996, which is 3. So this is years in the bottom and sunspots on the top. Okay, so N of 1999. So in 1999, let me erase again. In 1999, there were 93, and in 1996, there were 9. Okay, 93 minus 9 divided by 3. So what is that going to give me? 84 over 3. I think that should actually divide in nicely because 3 goes into 93 and 9. Okay, so let me think about this. 3 times... Okay, so I think that actually should divide in nicely because 93 and 9 were both divisible by 3. So what do we want? 3 times 30 would be 90. That's a little too big, so I think it's 28. 28 times 3. Always okay to use a calculator to check those, but I spotted that, so I figured I'd try and sort it out. Okay, so let's start with units. That was the number of sunspots over number of years. So for explaining, I wrote kind of big, so maybe try and sneak this in. I'm just gonna, well, here, I'll try and sneak it in down below. So so we'll say between 1996 and 1999, the number of sunspots increased, since it's positive, by 28 per year on average. So again, if we looked at all the values in between, I don't think we're going to see a perfect rate of increase. It goes from 9 to 21. That's not an increase of 28. And then 21 to 64, also not 28. But if you average out that total of 84 additional sunspots in 3 years, you'll get this average of 28 per year. We were also supposed to look at 1998 to 2003, and I think there was a specific reason I wanted to check out both. So let's calculate, and we'll see if I remember. Okay, 98 to 2003. Oh yeah, that's kind of an interesting one. I do see it. If we look at N of 2003 is 64 minus N of 1998, which is also 64, divided by 2003 minus 1998. I just wanted to point out here, we get 0 over something, which is 0. That what it will tell us is that it averages out to no change, basically 0 sunspots per year over that 5-year period. And that doesn't mean that there really wasn't any change. We can see what happened. It went from 64 all the way up to at least 120 and then back down to 64. So depending on how you pick your interval that you're calculating average rate of change, it can do a fairly good job of representing what happened, or it can do a not so great job and miss details like the peak in the middle. You can also, of course, get a negative rate of change if the amount actually decreased. So that was all I wanted to show for that part. All right, part D, what is the maximum number of sunspots recorded and when was the maximum reached? So this is like a local maximum question. There's a lot more data, so there could be a higher global maximum. But according to my table, if I'm looking at the number of sunspots in the bottom row, the biggest I see is 120. So our maximum is 120 spots in the year 2000. So that was our maximum. And then last question, when was the number of spots below 50% of the maximum? So we want to go 50% of 120 was our maximum, which is 60. And if we look back at our table, it looks like, okay, so less than 60, 96, 97, all too high, 2004, 2005, 2006. So based on this data, it looks like anything before 1998 or after 2003. But I would say we don't know what happens outside of this table, so maybe it's best to just list the years. So I'm going to say in 1996, 1997, 2004, 2005, or 2006. So you can kind of interpret the situation and see if you feel comfortable making the little bit more general statement of before and after. But I'm just going to go with that for this one. That seems like a reasonable way to do it. And if you ever answer and you feel like you lost points over something that you thought about, you just come and explain to me what you were thinking, and I am happy to look at that again. Sometimes I just don't catch what you were thinking. All right, thanks for watching.